Hello everyone, this is Shweta Patil from Department of E&TC, AISSMS, Institute of Information Technology, Pune. Today we will discuss the topic FIFO Page Replacement Algorithm. So, the first in first out algorithm is the simplest algorithm of all. This algorithm, it is associated with each page the time when that page was brought into the memory. In this algorithm, the oldest page is chosen for replacement. This algorithm assumes that a page which is fetched into the memory a long time ago may not be used in the future. FIFO algorithm gives the poor hit ratio. Due to locality of execution, there will be regions of program or data that are heavily used throughout the life of the program. These pages will be repeatedly swapped in and swapped out by the FIFO algorithm. The working of the FIFO algorithm can be understood with the reference strings. We will consider the example in the next slide. So, to calculate the total number of page hits, the formula is given as total number of reference minus total number of page miss or page faults, and the hit ratio is calculated by total number of page hits upon total number of references. So here we have a problem. A system which uses 3 page frames for storing processes page in the main memory. It uses the first in first out page replacement policies. So assuming that all the page frames are initially empty, what is the total number of page faults that will occur while processing the page reference string which is given below? So this is the string which is given 47617617272 reference string which is given, and we are supposed to find the total number of page faults and the hit ratio. So above is the given problem. We have the reference string which is given. We will draw the main memory. And then divide this main memory into 3 parts, as they have mentioned that the system is using 3 page frames. We will write this string here 4 7 6 1 7 6 1 2 7 and 2. So this is the reference string which is given, and we are going to use these pages into the frames with the help of first in first out page replacement policy. So this initially the memory is empty. The first page which should be replaced is page number 4. The page number 4 will be allocated in the frame 1. Next, there are 2 frames which are empty. The next page is page number 7. So we will keep this page number 4 as it is, and in the next frame we will replace the frame with page number 7. Still one frame is empty. Hence the next is 4 will be as it is, 7 as it is, and this page number 6 will be in the third frame. The next page number is page number 1. Now here we can see that all the 3 frames are there, which here we can see that all the 3 frames are filled. So we need to replace one page from these frames. According to the algorithm, the first frame, the first page which came in is going to be replaced. So page number 4 will be replaced by page number 1. 7 and 6 will be as it is. Next page is page number 7. As page number 7 already exists, we will write the same sequence again, 1, 7 and 6. The next sequence is 6. This also exists, so the sequence will remain same, 1, 7, 6. The next sequence is 1. What we can find is 1 also is present in the previous sequence. So 1, 7 and 6 will remain as it is. Next page is the page number 2. Now this page number 2 is not there in the previous pages. This page number 2 needs to be put in these frames, and one of the page which was first taken as an input will be replaced. So 1 here as it is. Page number 7 will be replaced by page number 2, as page number 7 was the first input, so it will go the first out, and 6 will remain as it is. Next is 7. So 7 is not there in the previous page frames. This 7 will be replacing the page number 6, so we write 7 here. Next page is 2. Page number 2 is already there in the previous sequence, so this sequence will be as it is, 1, 2 and 7. So this is how we have completed the reference string with the help of FIFO algorithm. Now we will find out how many hits and how many faults are there. So first page is the fault page, as the page sequence does not remain same. Here also there is a fault page. Here also this page is a fault page. This page also is a fault page. But here what we can see, the previous sequence and the next sequence is same. The sequence does not change, 1, 1, 7, 7 and 6, 6. That means this page is hit page. Here also 1, 7, 6. This is also a hit page. 1, 7, 6. This page is also a hit. Here this page is not a hit because we have replaced 7 by 2. So this is a fault page. This is a fault page. Here the sequence remains same. That means again we have received a hit. So we will calculate the total number of hits. Total number of hits in the given sequence are 1, 2, 3 and 4. So we have 4 hits with us, and number of faults are 1, 2, 3, 4, 5 and 6. So there are 6 faults and 4 hits here, and the hit ratio, we have already seen the formula for hit ratio. So the formula for hit ratio is the total number of page hits, here it is 4, upon the total number of reference. How many references we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 reference. So hit ratio is going to be 0.4, or we can also say it is 40%. So for this problem we have the solution, that is hit ratio is 40%, with the help of first in first out page replacement algorithm. Thank you.